and the template's mine. So this is a problem dealing with finite differences, and we want to make an equation to fit this data. So as you can see, I can draw in pictures. So at 0 stacks or 0 layers, I have 0 oranges. If I have 1 layer, I have 1 orange, so that's filled in. I have 1, 2, 3, and in the back I'd have another orange, so that's the total of 5. So what they want us to do is fill in this table with how many oranges there are at each level. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9 more past this, I'm going to have 14 total. So why don't you take a minute, try and fill in this table, and then we'll go to our next step. I should be able to fill in this table. 30, and then 6. Oh, no, that's wrong. Editing this out, right? So then we can get to our finite differences. So 1, 4, 9, 16, 25, 36. And as you can see, there's a nice pattern here that'll help us with our recursive. But if we want to find the function, we just keep going with our differences. Here's 3, 5, 7, 9, 11. And then our last difference, 2, 2, 2, and 2. So as you can see, here's our first difference, here's our second, and we went all the way to the third, which means this is going to be a cubic. So we have our general cubic equation, an cubed plus bn squared plus cn plus d. And we can make our general system of equations. So we could use n equals 0, but let's use n equals 1 to get our 4 by 4 matrix here. So when n equals 1, I get a 1a plus 1b plus 1c plus d. Just by plugging in that n value, notice I get a 1 cubed, a 1 squared, a c times 1, and then a d. We can also do an n equals 2, so that would give me an 8a plus 4b plus 2c plus d. 27a plus, let's see here, 9b plus 3c plus d. And then when n equals 4, 64a plus 16b plus 4c plus d. So it looks like a lot of work, but you can find the patterns that this is just going to be the cubed row of your n values, the squared row, your actual n values, and then you have a whole bunch of d's. So this is set up nice that we can make our matrix now. What we want to do is then see what they're equal to. So the blue equation, when n equals 1, we always go back to our table. So when n equals 1, we have it equal to 1. So there's our blue step. Our red step is when n equals 2. The answer should be 5. The green step is when n equals 3. And I actually wrote it in blue, but hopefully you see that's 14. Then lastly in our table, we have when n equals 4. Erase that for a second. That's the one I'm looking at. So it should equal 30. So we can set up our matrices now to have a 4 by 4, and then we have our answer matrix. And by doing that, we can use our inverses like we did in class, and that should be able to find you the A, B, C, and D. That will get you the function that makes this sequence.
Okay.